Hello, everyone. Hello, guys. Can everyone hear me? Okay.
Yes.
Awesome. Awesome. So, welcome to the session. I think we will wait 2 more minutes and we will start the session. Meanwhile, I pass around the GitHub link, so please take a look at it. You can find the session in the Azure class link. So let me know if you can access the link, all right? Once you go there, you go to the presentation and then you click on the Azure class to access the link. Hello, Jude. Welcome to the session. Oh, okay, sorry. Let me pass the link again. So we will refer to this GitHub link, and this GitHub link, we will have everything from the presentation slides to the Colab notebook, so that we can practice on Colab later on if time permitted. All right, so before the session, I want to ask everyone, so how many of you have experience with Spark or know about Spark or know about the distributed system, and what level of familiarity that you guys have with this? Oh, awesome. Oh, you work with Spark. That's awesome. So you will have a lot of input then. So just so everyone knows, so this session is introduction. So you will get to know like what is Spark, how Spark work, and how to set up a collab notebook on Spark to so that you know you can start like trying some syntax, some Spark SQL on it. I'm thinking of doing 2 series. So for today, we will just focus on the introduction, and we have I believe, the machine learning phase in the upcoming week. And on that session, I'm thinking about doing some hand-on demo with trying the Spark ML libraries on Colab to see how it works. I also haven't tried it on Colab, so it would be a very interesting experience for me also. So just let you guys know that there's something upcoming. So all right. So it's 3:05 now, and let's start our session. So hope you guys can see my screen sharing all right. And for today's session, I have a big thanks to Pratisha. She helped me prepare the poster and helped me post on channels, and also with Muhammad. He also helped me like spread the word out. So thank you guys. So let's start. So I briefly introduce today the content. We will briefly talk about the distributed system.
Jin, I'm
Yes.
really sorry to interrupt you in between your session. First of all, do take it. I look forward to take it whole. This webinar is going to rock. Thank you so much.
Okay, thank you so much, Ali. Yes, so everyone, please remember to fill in the sign-in form to be counted as participant. So anyway, so if you have been joining my other Spark sessions, you know that I have been doing the Spark training for a while. And today I want to add a new module in, which is the distributed system, because I felt like it's time for me to carry in depth introduce this. And also, as you know, I also run the channel on the preparing people for the data certifications in the Azure. And one of the certification is about data engineer, which is DP 200 and DP 201, which I'm going to take it myself also. And there's a lot of questions on distributed system, on the theories. Well, if you understand it in depth, it would be better. So that's why I want to incorporate some of the elements in to help you introduce you to it. And also you will have, hopefully you will have an easier time when you take the exam. So we will go through just a basic intro of distributed system. What is why we need to distribute the system, some of the fallacies, some of the pitfalls, and some of the famous theorem, which is CAP theorem. And after that, we will go to our usual introduction to Spark and Spark API. So if you guys have been in my other sessions, then this module will be surprise you. And the last one is how to set up a standalone Spark on Colab. I ran this before, but then recently there's some syntax or some update changes. So I updated the code, and you guys will see this. So let's start. So I hope everyone have the access to the GitHub content already. If not, please let me know. Please click in it, and all of the materials will be preferred from this. So for this presentation, I will use the presentation from the Azure class. Please click on it and you will see this presentation. So let's talk about a distributed system. You know, what is why we distribute a system, and what are the fallacies, because in every system there's a pro and cons, right? And we will talk about distributed data store, because you know you have so many different, when you heard about distributed system, there's so many different way. And the last part will focus on data store, and we will talk about you know, ACID model, which is usually used for relational database, and base, which is normally used for non-relational database, you know, no SQL, and CAP theorem, which is like our guideline of how to build a system. So what is a distributed system from you guys thought? So have anyone have experience with distributed system? How do you guys feel about it, working with it? I share for a little. Okay, so so basically, distributed system is a group of computer working together as appear as a single computer to the end user. So if I work with a distributed system, supposedly I should carry on with my usual command. I shouldn't notice any difference in the background because it will appear at one computer only. But the back end underlying it is composed with different driver and different executor to carry out the task in the breakdown scope of work. So if you look at the left side, you can see the client machine who will send the commands to execute it. And once and the command could be like analyze, scheduling, monitor, and this command will be sent to the driver, and the driver will distribute the task to executors to run the task. So in the client side, you wouldn't notice anything different usual than if you would run in the normal cluster. Of course, there would be difference in like syntax and how you should write your code, but then otherwise there shouldn't be any noticeable. Yes, Muhammad said, dividing big data into chunks, and that's a very, very important pros of the distributed system. So the executor is responsible for actually executing the works that are assigned to them. So that means each executor is responsible for only two things. Execute the code that assigned for it by the driver and report the state of computing back to the driver node. So this is how Spark distributed system work, and it would be how other similar distributed system works too. So let's go to a further model. So when you look at this cluster, you can see that the driver send the message to the worker, and the worker acts as an executor to execute our task and report back to the driver. So in Spark, we have a cluster of machines that leverage the execution task and will be managed by a cluster manager. So like you can have Yarn, you can have Mesos, you can have Kubernetes, depends on the system framework that you use. So next, we will talk about why we distribute the system. What is the benefit on that? So to talk about it, we will need to look at the vertical scaling and horizontal scaling. So vertical scaling, basically you have one machine, and it's binded to the ability to upgrade it limit to, like you add more RAM, you add more CPU, you get the latest hardware, but then it's binded to one existing machine only. However, horizontal scaling is that you keep adding computers in to become a cluster. So you can have like Raspberry Pi. I actually have seen people building it. Actually, so you have Raspberry Pi, right? So each time you want to scale horizontally, you add another Pi in. So it's horizontal scaling of how a distributed system works. Are you guys all right with this so far? Okay, so that's one of the benefits of the distributed system is that scalability, and it's really work well when you have a big chunk of data that cannot be that is very costly to build it in the vertical, costly to process it in one existing machine. And this is where the shine of the distributed system is in, is that like you process it with multiple different machines. So next thing is the fault tolerance. So because when you look back at this machine stage, so you can see that this machine stage share only share the operate concurrency, so it can fail independently without affecting the whole system. So like for example, if this executor node, one of it failed, you still have like other executor node. You can, one worker is failed. Let me go back to it. So for example, if one worker failed, you have 3 other workers to rely on to run their task. So that is called fault tolerance. So another benefit is low latency. So in one scenarios where you can have a distributed system across multiple towns or multiple geography locations. So it's allow the traffic to hit the node that is closest to it. So remember, there's 3 benefits of the distributed system. So let's talk about this. So let's have a look about distribution pitfall, because a lot of people try to avoid having a distribution system as much as possible. Oops, sorry, I forgot to change the slide. Yes, sorry guys. So a lot of people try to avoid the building the distribution system as much as possible because of this. There's a fallacies. Distribution system is not easy to work into because there are so many pitfalls that people compare it to like walking into the landmine, and you need to understand the constraints to be able to design the system effectively, especially with DATASTORE and how to work with it. So this is just for the system. For this system design, we will talk about some of the pitfalls that I experienced with the DATASTORE later on. So I want you guys to click on the link because I think this is a very good material. I also copy it from there, and you guys can read about like each of the age later on. Can you guys open it? Yes, thank you, Harris. So you guys click on. Okay. So when you guys have time, you guys can read about each of it later. So in this scope of class, we will just talk about. We will just briefly introduce about 8 of the fallacies, and this only mostly matter when you do system administration and the system design. So we have network network fallacy. It means that people assume that there's no problem, so they assume that network is reliable. But in fact, you guys know, there is issue with network, there is issue with latencies, there is issue with bandwidth, topology, things like the network issues that you need to be concerned of when you design a system. So basically, what these 8 fallacies talk about. So let's go to the next slides. So okay, so let's talk about distribution system in the DATASTORE. So let's click about, so in DATASTORE, as you guys know, there's a relational and non-relational data store. So a relational data store is built around ACID model. So ACID model consistent of atomicity, consistency, isolation, and durability. So the focus of relational database is on consistency and availability, while that base is normally used for non-relational database and NoSQL, and it's the opposite spectrum from ACID. So it focuses on partition tolerance and availability, and with consistency is okay. So when you look at the consistency, you might have a question, what is it? What is the consistency? So I want to invite you to click on the link here. I was preparing for the DP200. So I also saw in the Azure Cosmos DB, there's different options of choosing like different type of consistency. So that's what it inspired me to write this article. And please go through it if you also prepare for Azure DP200. I already put some articles relating to the exam content on here. So you can take a look, and we will have another study groups around, I believe, November to prepare for this exam. So in here, I talk about like different type of consistency, and what it is, when does the consistency arise, and why we need to take a look at the consistency, and what are some of the models. So you guys can have a look at that. But before you guys read any further on consistency, let me introduce you to the gap theorem model, because it will help you understand this. Okay, so this is the THEOREM model, and if you have been reading, if you guys have been reading articles or like solutions articles from AWS, Azure, you go about DATASTORE, you will see this all the time because this is the core of distributed data store. Anytime when you read about MongoDB, you read about you know, NoSQL, things like that, you will see people prefer to this model. And actually, I have very good resource on that I would like to invite you guys to have a look for further information. So, because this session, we will just introduce briefly to the concept. As a distributed system, it normally takes a semester for a school to teach, to be able to fully understand about the system. So instead, I have a very good resource from Professor Lindsay Cooper that I have found in September, I think in the March this year. She talked very, very well on distributed system, and she covered like most influential papers on this topic. So if you guys have time, check this link out. It's very, very detailed. I love it. And also DynamoDB, this is one of the most influential paper that have been written in the past decade on the distributed system. So yes, this is a paper, and I actually participated in a interview with a school from Bradfield, sorry, and a lot of questions about system design was referring to this paper. So if you guys have time, definitely check it out. So anyway, let's go back to CAP theorem. Sorry, I was a little bit sidetracked. So this is also a very good link on this. Also, it's talk about what I have been discussing about vertical scaling, horizontal scaling, and you know, like different type of scaling and how it works. But I want you guys to go to this part where they discussed about like 3 components of CAP theorem. So let's go here first so that I can discuss with you on basically what is the 3 component. So basically, consistency is you have to have the up-to-date copy of the data. High availability is that the data is highly available and up for the updates. So you know you have the available to like queries to perform data analysis on that. And tolerance for network or partition tolerance. That means sometimes the node will be disconnected, will be you won't hear from the node, and the system need to continue to operate despite the message being dropped or delays between the network of the nodes. So basically this, and what this theory say that you only can have 2 out of 3. You cannot have 3 components together. So you can focus on either CP, which is consistency, or partition tolerance, or you have CA, which is consistency and availability, but you cannot have all 3. So this is what you need to consider when you design a data store, distributed data store, or distributed system. So back in here, you can see this CAP theorem, right? We talk about the 3 components of the shared data system, and different model here. You know, you can have consistent available. So I invite you to read more on this because the limited of our today's session, which is I only be able to give you a basic overview of this instead of the hardcore and deep dive into this. But this is a very, very good explanation of what I talk about. So let's start with this. Some of the pitfalls that I experienced while working with the distribution data store. So firstly, we need to talk about sharding. And the pro of sharding is that it really helps. Sorry, let me also the sharding is primarily used for distributing data for horizontal scaling. There's pros and cons, and you need to take a look at whether your data store needs sharding or not, because it can cause bottleneck, it can cause it can cause longer time to queries, and it's also reduce the efficiency of your system. So it's also a part of the DP200. Oh, shoot. I got the wrong link, so I'll fix this. But let me go back here to share with you about the sharding. Because one of the modules in the DP200 is optimize your data solution. And I was reading the articles and the different documents on that, and it was mentioned about sharding and partitioning. Oh, also, let me mention a little bit about sharding and partitioning. What is the difference and what is the similar? So sharding and partitioning are both about breaking up data into smaller subsets, right? So you have sharding, you also have vertical sharding and horizontal sharding, and similar with partitioning. The difference is that sharding implies that data will spread across multiple computers, while partitioning is more focused on that you have the data in one single server. Right? So the advantage, of course, you can see fewer hardware or software requirements, right? You don't need to have like expensive server, because as I mentioned, sharding is mainly work with the distributed system. So you can have like less expensive server that work throughout a cluster, that work with a cluster, and that is then these individual components of the cluster, the individual component of the server work in a cluster, give the strength to the whole system at all. So that's what I meant by less expensive server. However, the disadvantage is this below. So you need to consider um, when you are produce a sharding keys, and you are trying to map the sharding and how to divide it. So after the session, please go and check it. So also, when I mentioned about the sharding keys, the bottleneck caused by it and how to reduce it. So I really love this MongoDB documents on introduce about sharding. What is it? What is sharding cluster, and the strategy to produce and reduce the sorry. So in this, it talk about best practice of the shard keys and how to design shard keys that will help you later on, and avoid things such as like shard key value bottleneck. So take a look at that. So another issue that I was experienced with DATASTORE, which is join queries, and this is the issue that a lot of people from the data team, when they first work with distributed system, have. So I'll tell you a story. When I first work, when my company first implemented Spark, there's I was responsible to translate some of the legacy script from Python to PySpark, and I didn't know much about Spark, and well, I did know Spark, but I didn't know much about the underlying of the distributed system work back then. So I saw pandas in the Zeppelin notebook, right? And I saw that it working. And like, great. So my task could be easy. I just need to use, the Python script that's used for machine learning model that I have in another system. I just need to bring it here, right? Because Panda works, And if I cannot use Panda, I will use Coalesce, which is the version of Panda API, but for distributed system, right? So I was so happy. I was so innocent, and when I hit, when you use pandas. So basically, when you use Panda in the distributed system, we will collect all of the data from different nodes to one server. And what would be the result of that is overload that particular, sorry, I should say particular server, or not cluster, sorry. So it overload that particular server and it caused that server to go down. So I have to restart my whole session again. So that's what happened when you need to, when you use join queries or any queries that gather the data from across the cluster into one single machine. Because the advantage of the distributed system is that you don't need to use expensive server. So each server is already weak, but then you divide the task among server to help it calculate and perform efficiently. So when you do join or when you collect the data into one source, it will likely to cause the system to be overloaded. So that is one of my painful experience that I share with you guys in hope that you guys don't do like me. Okay, so let's go back and go with the Sparks topic. So I have been talking about distributed system, and you guys know by now that Spark is built on distributed system. So we will share some of the components that I have talked about. Okay, let me move all the. Okay, so you guys, when you guys see here on the distributed file system, so before Spark, there is Hadoop, right? So the reason why people move from Hadoop to Spark because Spark is faster, and it also support more languages, which is Python, Scala, Java, and R to help people from different backgrounds, for example, data analysts, data science, to use Spark more efficiently. So and also there's other products that you can use about Spark on the cloud. For example, Databricks, you might have heard, and for Azure is Azure HD Insight that leverage the Spark and distributed system to run analysis and machine learning. So the core of Spark is that you have the distribute. Oh, sorry, I think there's some question here. No, Spark cannot work without a distributed file system. There must be a distributed file system for it. I was answering truth, so yes, it must be distributed file system. So the distributed file system that I use is HDFS, which is Hadoop distributed file system, and there's many different file system that is used in distributed also. It's another topic that maybe I'll add in another days, but it's not, when you talk about distributed file system, it's not limited to HDFS. It's just what people normally use to run Spark on top of it. So at the base level, we have the Hadoop as a distributed file system. And I mentioned about a resource manager to manage the resource between the executor, the worker, and the node is Yarn and Mesos. And then we have the compute engine, which is Spark Core. And on top of that, we have the API that we use to leverage and do analytics and to interacting with Spark. So we have Spark Streaming, we have GraphX, MLlink, and Spark SQL. And Spark SQL is the one that I used to talk about when in the last sessions. But in this session, I'll introduce you to notebooks that have different contexts, because what happened is that I'm recently studying for Cloudera. So if you have the look in the market nowadays, you have two exams for Spark. One is Cloudera, I believe CCA 175, which is really costly. It's about, I think, about $200 per certificate. And another one is Databricks Spark also. That one is a little bit cheaper, $80, but then it more focused on Spark on cloud. So depends on where you want to take your career. You can have that two choice on Spark. So for Spark on Cloudera, they require a deeper understanding than just Spark SQL. So that's why I produce a new collab notebook that have some questions that simulate to what Cloudera might have asked, and I need to continue to work on that. But now when you look at my GitHub, there's two options for you to choose from. You can try the Spark SQL with my old notebook, which I have updated code to make the Spark work. Spark standalone works on there, or you can take a look at my Cloudera notebook where you need more, where there's deeper than just Spark SQL. All right, so okay, so why Spark? You know, Spark is used for machine learning, interactive analysis, and so many other fields, because big data become popular, and Spark is also gaining the reputation also. So you know, if you look around the job posts online, there's a lot of requirements for data engineer that have experience with big data. Also, data for the data scientist job posts, I also see some, but not as popular. But you know, there's a field for data scientists in big data that you could take a look, that would likely to require your understanding Spark and some knowledge in Scala. Mainly, I see it in from the data engineer. Why there's more requirement and demand on that. So folks here who are data science and work with Sparks, please let me know how the job market wise for using Spark in data science. I have very little knowledge on that because I'm in the data engineer side. But job-wise, if you look at companies like Netflix, Uber, Pinterest, you know, even Home Credit, we are starting to use Spark in our system also. So it's getting more and more popular. Along with that, then we have PySpark. We have that you can use for like Spark SQL to query our data, and we have Scala for like particularly when you use UDF, which is user-defined functions. Although there's newer version of Spark, which is Spark 3, that make Python and Scala more closer together. I still believe that there's some useful field to learning Scala. So let's talk about this. Okay. So as I mentioned about the Spark ecosystem is Spark SQL, streaming MLlib, which is used for machine learning. I want to mention also for Azure, there also Azure ML, which is a library that you can use for machine learning on Spark, and you can actually install it on premise. I did implement it on the on premise on my cluster, so I know that it works also. And one of the things that I really like is that it supports live GPM model, which are not support in other libraries from Databricks or from Spark ML. I haven't go deep into the algorithm of live GPM, so I wouldn't know the details how the Microsoft live GPM different from the original live GPM from scikit-learn libraries, for example. But I know that it works and it's there. So if you're looking to work with a live GPM model on Spark, it would be an option. So of course, you know, Spark AI, so and GraphX, which is other component on the Spark ecosystem. But what I want to highlight is that there's Apache Spark Core API. So these are the, oops, sorry, I forgot to change the slide again. Okay, super sorry for that. Okay, hope you guys can see it now. So R, SQL, Python, Scala, and Java. Python is normally the default language to use, at least in my company, for interacting with the Spark cluster. But I know there's other job posts that really emphasize on the Scala use. And but then, as I mentioned, for the Spark 3, Python and Scala gap is bringing closer and closer together. So if you don't have experience with Scala or Java, it's all right. Focus on Python. Okay, so I have been mentioned briefly. Oh, there's a question for me. Just a moment. Yes. Muhammad, please.
Okay, Jane, how can I integrate SQL with Spark? I work with Python, but not SQL.
Oh, there's a Spark SQL module on it. I'll show you the notebook soon, and you can see how you can use Spark SQL on that. So basically,
Okay.
yeah, it's just a module. It's very easy. It's super easy. So I'll show you a notebook on that. Sorry. So we have talked about briefly what is Spark. Oh, fast expressive cluster of computing, compatible with Apache Hadoop, and it improves efficiency through in-memory computing and general computing graph. So let's talk about why Spark. So it has large community support. It's faster and easier than Hadoop and MapReduce, because with Hadoop and MapReduce, you need to know Java. In Spark, you have the option with Python, with R, and it's have a really rich APIs environment and support. Yeah, and it support batch application, streaming application, machine learning, graph processing. So there's a lot of workloads that Spark can handle. So again, this slide, it refer back to the distributed system model. So Spark is a distributed system model. So it's driver and executor, and we have talked about that. So let's talk about Spark API, because this is very interesting, and you will see a lot of confusion in this when you start with Spark. So originally, when Spark come out, it go with RDD, right? And it's 2011. Remember this time frame, because I'll tell you why later on. So you will see like a lot of map, filter, etc. So in the 2013, they come up with the data frame. So you have an option with writing UDF. It's fast, it's efficient, and it's have the panda-like method in terms of like it arranges things into data frame. And in 2015, you have the Java set. I haven't used it because it only support Java and Scala. It has a support Python, so I haven't had chance to use this yet. So why I mentioned about the data frame, the time here, because if you look at Stack Overflows, for example, if you were finding ways to like make things work, and you look at the Stack Overflows also, sometimes you see like the same issue, the same question. Some people use like math, filter, lambda. Some people just like write one sentence and that's it. That's because of this. Some people use RDD. Well, when there's no option, back in 2011, there's only RDD. People use RDD. 2013 data frame. So when you look at the Stack Overflows, you need to notice this difference to choose your mentor, to choose the mentor of code that you work carefully. So as I know, like some people like really still stick with RDD because it allow for it's allowed for like a really flexible, really low level programming. So that is, and also, people have it if they already spend time with RDD and they're used to it. So it could be the way that they write the code and answer your question on Stack Overflow. So that is something that you need to remember, and you need to pay attention to. Also, remember, even though we have data set, data frame, everything is still go back to RDD, because RDD is the core fundamental of Spark API. So even if you work to data frame, it just means that there's a translate underneath that refer back to RDD, so that you don't have to do it manually. So here's some comparison of different API. What is the pro and con and the supported language. So you can read on it later on. But for the class focus, I would recommend you to start with data frame and start with Spark SQL in particular, so that you get familiar with the framework. And then if you want to have like really low level programming, something specifically that you can address with data frame, then you can go ahead with RDD for data set. Unfortunately, I haven't been able to mess with it for a little bit, so I haven't had much experience with it. So I'll skip this and I'll just put it here for reference. Okay, so Spark API. This is very, very important. We get into the important part because remember, when I was telling you that I made a mistake when I was doing some of my first Spark task, that I call every single data that I want into one machine, right? So that is the concept that related to lazy evaluation in Spark. So Spark API, there's two types, the transformation and the action. So when you write things, certain action, for example, like select, group by, order by, join, they when you write it won't do anything. So Spark will just let it there, but then when you tell them to action, which is like to compute, then it will start compute, and that's where you will have like crash, you will have like issues if you do what I did, what I mentioned with you. So when you do like count, show, that is where you have issue. So lazy evaluation, what is it? So lazy evaluation is like when you go to a restaurant, you order food, you and your friends, your family order food, the waiter, they're not gonna run back to the kitchen every single time you order food, but then they will take a note of it in a menu. And then once you finish with all of your order, they will go to the kitchen and they will say, okay, please make it for me. And that is the action in terms of Spark. That is where all the computing is starting to compute, and they will start to join, they will start to take data, they will start to compute all of this, and that's where your issues will start to arise. But when you just write to take order, there will be nothing rise up yet. So this is just basically different persistence to optimize, because remember, RDD is persist. Oh, and let's talk a little bit about mutable and immutable in the Spark. I remember I put a slide on this, but okay, I guess I actually delete that slide. So let's talk a little bit on this. So in Spark, we have the concept of immutable data frame. So, your data frame is non-changeable, it's immutable. So that means like you cannot change it. If you want to change a data frame, you need to create a new data frame. So that is number one. Number two is lazy evaluate. So Spark is lazy evaluate. So sorry. So for lazy evaluate, so you don't it will wait for you to perform the action, to hit the action command, certain action command group to evaluate. And number three is that because of those two, then sometimes you would want to persist what you compute in the data frame, because after a while you don't use, and it go back to the lazy evaluation. That means it will wait for you to call for the action before it start to compute again. So if you want Spark to remember, then you need to catch it. So this is only the method of catching, so that your data frame is written and you don't have to compute again. All right, so let's go to the Spark SQL. Sorry, I think there's some question. Okay, no questions so far. So as I mentioned, there's a three way to get the data. So there's RDD way, there's data frame way, and there's Spark SQL way. So Spark SQL is the most popular for Spark module because it's exactly like how you would write normal SQL. So you can see here the Databricks notebook and the programming guide. But we also have the option with our own notebook that we will start now. So yes. Okay. Do you guys have any Q&A before we start to move on with the notebook on Colab? Okay. So no questions so far. So let's. Oh, I think there's one question. Awesome. Thank you so much, Muhammad. So let's go to the Colab notebook. So I'll introduce you a little bit about these three notebooks that I have and how you can use them. For today, we won't go into details of like how to run them because you can try to hit run later on in your own time. But I'll just introduce about like what it is, my purpose, and how you should use them. Okay, so set up Spark, you always need to get like all the app updates to the latest. So this is very important. I fixed it from other notebook as well. So if you participate in my other sessions, you will see like before, back in the beginning of this year, I was writing like a real long code to like set up Spark to work on here on the Colab, right? So somehow that method didn't work anymore. So I go back and I see that there's a new way and it's very shorter, just 3 lines. So I fix all of it. So please update the other notebook also. So, and you mount data and you import drive, and you start to read CSV. This error come from that the link that I try to use in not exists, but you can disregard it. Just make sure you have the right location in the print schema. So these are all the old content. Here the new content on the practice question for CSV format. So this notebook is particularly for CCA 175. So in this certificate, you will be asked to how to work, like how to read and write with different data source. So CSV packet, text. I think there's a few other one. So, that I don't remember, so I have to look at it. And also they will ask you on like how to write in RDD, how to write it in the other ways, so you need to remember it by heart because in the exam there will be lab and there won't be time for you to take a look at to Googling the syntax. So that is the purpose of this notebook, and you will see that in here. I don't really use SQL syntax like I do with other notebook. So if you want to have something that more deeper is Spark, then you can take a look at this. Yes, and you see the packet, raw text, read, write, data frame in different formats. It's a concentration of this CCA 175 certification. So that is that for the Spark training for this cert. So for the Spark SQL, I believe I update it a little bit. Okay, so let me go through with you guys with this. These are just basically to measure the performance. You can install, you don't need to, you can, or you can remove it, it's all right. Basically, this is the code to check to see like what Google, what Colab give me. So, no need to pay attention to this. Let me go to the main components. Spark measure is where you can have with measure and debugging your code. In the Hadoop cluster, you have the Spark UI where you can monitor your Spark job, but then it also doesn't help with monitor particular line. So that's where Spark measure come from. All right, and this is the SQL part. Muhammad, so basically you Spark SQL, .SQL, and then you just start writing normal SQL schema. So it's just like this. Yeah, I know, that's really easy. So that's why like I really love to use Spark SQL first, and then for all the more complex, then I start to use good order. But yes, that is for Spark SQL, and I'll put the notebook here for you guys to explore more on that. All right, so yeah, it's very easy. Let me see what are the notebooks that I have. I think this one is basically the same, but yes, this is basically the same, but without the Spark measure. So I'll delete this one actually because this doesn't bring any value. So I'll delete this one. Please just use the latter two links to play around with Spark. And in the next session, in next week, I'll do two sessions. One session is introduce about different data certifications in Azure, and I'll try to see if I can work out some, simple Spark machine learning model, Spark machine learning training on the Colab. And if I work out, then I'll see you guys, and we have another session with Spark on that. All right, so that's it for my presentation today. Do you guys have any questions or anything that you would like to ask me? If not, then I think our session would be concluded. Thank you, Jude. Thank you. I hope everyone will.
Thanks, Jane. This was a nice session.
Yeah, thank you.
Yeah, and I'll be moving toward SQL. I'll experiment with it.
Yeah,
To find.
definitely. Yeah. Definitely, it's very easy to like get the data and start.
Yeah, it's very easy because having a good SQL knowledge, you can easily switch towards it, and
Mhm.
Spark will be a good for a big data tool with SQL.
Totally. So, Muhammad, you mentioned about you work with Spark and you are a data scientist, right? So, could you share?
Yes.
Yes, could you share with us a little bit how the Spark landscape in data scientists, like how is in terms of like the employment ability, like is they for data scientists is Spark is really important, or it's just an add-on skill?
Well, it is really important if you are working with real-time data
Mm.
because because the decisions that were made during runtime, if you are not able to use this, your data will have no value. Like in
Oh.
my industry, we use it to measure the customer churn, what we are expecting,
Mm-hmm.
or the customer lifetime value, and the time we are going to use to provide service to customers. So
Oh.
if we cannot predict this in real time, we cannot afford machine learning algorithm for us.
Oh. Okay.
So this was basically an experiment from my department. We are trying to convince our management to move toward big data to
Mm-hmm.
use this technology. So we had used our data center used a Python created a Python link to our data center and
Mm-hmm.
used some servers on Hadoop to run Spark.
Oh, nice. Oh, nice. So, yeah, for streaming, you guys plan to use Spark streaming or Kafka streaming for that regard?
Well, it depends. If we got approval for the pilot project, then yes, we will be moving forward with it. It
Oh,
was just a test run.
awesome. Just a note though, for Kafka streaming, it's not support Python yet because there's another guy in my team is working with Kafka, and now he have to pick up on Scala for that. So,
Well, the biggest problem I'm facing right now is there is no like basic setup for what a data scientist or what a big data tools would be. There are so many,
Totally.
and the one you are working, your people in the industry is working with something else. So unless we have some standard that will be used, we cannot find the people with the right expertise. So everyone will have something different. Like someone is using AWS, someone is using Azure, and very few people who have the strong commitment and strong understanding of all these clouds or all the systems.
Mm-hmm.
So this thing till we have a standardized body, we will have the problem in this field.
Mm-hmm. Yeah, that's true. That's good thing that though that you guys are gonna do it on cloud. My company do it on prem. It's much worse. Yeah, because on prem you have to like do the whole provisioning and setup and everything.
Mm.
For cloud, at least you can have some automation on that. So don't worry about that. Yeah. But for Azure, I really like their Azure ML, which is like different libraries that they produce for Spark or like distributed system. So
Well, I believe this is the future of machine learning. We need the people who have understanding and who can change the AutoML patterns with little scripts.
totally, totally. Good luck for your project, Muhammad, and let me know if you need help.
Yeah, sure. I'm looking for some good people to for help
Yeah,
every now and
totally.
then.
Yeah. Oh, if you guys want, you guys can keep in touch with me on LinkedIn. I'm happy to answer questions on the Spark related. You know, just in case if I don't know if this Slack workspace could be deleted after our program finish, but you know, just in case, then you guys hear me on LinkedIn and you guys can connect with me and ask more about Sparks and distributed system. My study more concentrate on distributed systems, Spark, and cloud. So keep in touch and let me know. Yes. So
Okay, thank you, Jane.
yeah, you're welcome. You're welcome. So anyone with other questions on Spark?
Jan, one question. So you said your like in your team you are trying to do streaming on Spark, and it is not supported in Python. So it's supported in Python, right? It's supported in both. In fact, Kafka streaming is not available in Python, but Spark streaming is there, right?
I haven't tried with Spark streaming because the problem was introduced to us is already exists in the Kafka. So we were trying to implement the Kafka solution, and it's not supported in the Python. I didn't work with it directly, but the guy who was responsible for this project have to start pick up on Kafka and or Java. So either Kafka, Java, and he need to start working with implement uh, Kafka with the distributed system that we have.
Actually, Kafka in itself has now introduced this streaming concept because so what they are saying is that instead of keeping the two infrastructure in place, okay, so even if you need to do streaming on top of Kafka, so earlier it was like Kafka plus Scala should be there, right, to do live real-time streaming, but now Kafka is saying that you don't need to have Spark itself, okay, so you can do the full thing in Kafka ecosystem itself. So basically,
Yes,
you just
yes,
keep one
totally.
infrastructure. And
Yes.
for that, actually, the API is only supported in Java for now. It's not in Python.
Yes.
But for Spark, it's actually supported in PySpark for this real-time streaming.
Oh, so you meant like Spark streaming, right?
Yeah.
Oh, okay. Let me mention with him on that. Yeah, I wasn't involved in the details, but for Kafka and I think the pre-exist solution, from what I heard, the pre-exist solution was in Kafka, and I need to integrate because before we didn't use a distributed system. We use something other solution on cloud. I cannot say particularly the name, but that solution is already integrated between Kafka to that cloud system, and now we need to bring it on-prem on distributed system. And that's why we have some really weird situation where we have to like bring Kafka to the Spark cluster. A Spark streaming could be the solution that, like you said, we could take a look later on.
Okay.
Yeah, but for now, poor him, he got to figure out Scala and Kafka and how to integrate it.
Yeah. And are you using this ML flow from Spark? ML flow?
I requested because the thing about my company is that I need to request thing in order for it to be installed on the on-prem cluster. Due to security, I cannot install it myself. There's people from the headquarters need to install it. They installed ML Flow, but then they didn't open the port for the ML Flow UI. So unfortunately, there's ML Flow component, but I cannot use it yet.
Okay.
Yes. But what is your question that you meant to ask for the ML Flow?
No, actually, so actually I have attended some webinars from Databricks where they have mentioned that, so they are basically, one of the webinar I attended, they were saying that they are running this modeling for hundreds of models every day on petabyte size of data, and everything is, handled through this ML flow.
Yes. Is that one of the application of ML Flow on Spark to manage different models and to register, to keep track of like what models you run recently, what is your previous run model. So it's really good for that. Yeah, but,
okay. But
yeah.
is it different from what we have in this Azure ML? In Azure ML, we have this experiment and runs, right? So this ML flow is something similar to that, or it's different?
It's very different because the one that I believe the one that we use for the class is Designer, right? Azure Designer, which gonna be yes.
But in Azure Designer on the left side, there were some assets, right? Like this experiments, runs, which is basically keeping track of all our, recent runs. Or
But I believe, sorry, I believe it's in the content of using because Azure Designer is it focused on low code and it's not good for like a full scale production. So if you have 100 models, I wouldn't recommend it to use with the designer because all of the drag and drop and designing.
Yeah, no. Actually, it's not about that drag and drop, but so in the later chapters, right? Like in chapter 5th or 6th, so they had this concept of creating the notebook and deploying the notebook also, right? So we can do it both ways. We can do it using that designer, but that designer is of course not production ready, sort of. But that deploying the notebook is also possible, right? In Azure ML.
Yes, you can do that. You can use the workspace to keep track of everything that happened in the different components in the Azure. Different people prefer different things. Some people prefer Azure Workspace. Some people prefer to use ML Flow to keep track of things. So.
Okay.
Unfortunately, I didn't use neither of them in the production, so it's hard for me to have the opinion. But yeah.
So what are you using right now in production for this
on production?
track?
It's only like on-prem one. So on-prem cluster, and that's it. It's very pale. I have to use Spark UI and to keep track of things.
Spark UI, okay.
And yes, and I need to wait for other. Like every time I need something new add into the cluster, I need to raise a ticket, and that the whole process of like working out communication, ensure that the ensure things that like fall into security and things, it take like weeks or months to be able to update with a new thing. So yeah. Very unfortunate.
But have you used this Databricks community cluster? They are giving this community cluster, right, with 15 GB of RAM as for free.
Yes, I did actually try the Azure Databricks cluster. I think it's cut off every day, like it's erased every 2 hours. So it's up to you. So I think Colab worked fine for me, so I didn't have much attention with Azure Databricks, but I mean Databricks in the Databricks community. But I know that it's cut off every 2 hours.
Databricks community is cut off every 2 hours, no?
Yes, for the you meant like for like training and doing some simple data on the Databricks, right?
Yes, yes. On the Databricks in community, not in Azure, but
Yes.
in the Databricks site itself. If you open this community one, then your cluster will keep on running as long as you are using. If you are not using, then it will basically delete that.
I mean,
cluster.
like if you interact, really, I remember when I was looking at it, it said like it's have the 2 hours limit, maybe 2 hours of not interacting with it. But I remember to see like the 2 hours limit on that. So maybe I'll take a look again. But then you have other options to. Oh, actually, I want to show you guys. Yeah. So for starting with Spark, you have a Databricks demo workbook, as you mentioned. We also have the Cloudera VM, which is like you download from Cloudera, and it is like a VM with pre-set of everything. Like you have Hive, you have Impala, you have Spark, you have OZ too. So you know the whole platform, the whole stack of Cloudera, where you can experience with it. And Collab standalone, which is what we just used. You know, very easy 3 lines of code to set up Spark standalone and work on that. Or you can do like standalone cluster on your machine. For PyCharm, it's very easy. You just need to install Java Spark. You make it to be a variable in your machine, and you can start using it. But sorry.
In fact, I have one of the recent webinar link from the Databricks. Okay, so where they have given there is 3 to 4 hour session on implementing an ML solution on Databricks from right from model building to the deploying it into production using ML forms. So if you want, we can share that link also.
Sure. Please share. I would be very interested in that also.
Okay. Yeah.
Thank you so much. Yes, please share it. I'll add it on the. I'll add it. On the training documents too. It's a very good information. Yes, because I see the ML flows that you have to gain the popularity also. So it would be a very good addition on that. So to conclude, if you guys remember to check out the YouTube channel from Professor Lindsay, it's really, really good. Very thorough. You will learn so much about distributed system. And if you understand the distributed system well, then once you go to Spark, you will have the easier time to leverage the Spark power. You can design your query so that it's optimized for Spark system. So, all right, I think we don't have any other questions. So thank you so much, everyone, for joining. Thank you for your input and your questions. So hopefully I will see you guys next week on, like doing some fun Spark ML and talking about different data certifications on the Azure. So look out for those webinars. All right, so thank you so much and have a good weekend. Bye-bye, guys.
Thank you. You too. Bye-bye.